Good day, viewers. You are welcome. How to solve for all the values of x that satisfy these logarithm equations. First thing is, we are going to note that because I'm going to apply some basic rules of logarithm here, like 2 or 3. So the first one is, let's say we have logarithm of c base a to the power of b. This gives 1 divided by b log c base a. So here is the first rule I'm going to apply in the questions. And the second one is, suppose you have a log b base a base c. This is going to give log b to the power of a base c. That is, a, which is the coefficient of logarithm, will come to the power of b. And the last one, the last rule I'm going to apply in this question is, if we have t raised to power of log r base t, this gives r. And let's back to the questions. As I've already stated all the laws we are going to apply to make this question possible to solve. Here we have 5 to the power of log x base 5 raised to the power of 2 equals x to the power of 2. For the first law, we take 2 to the power to the back of logarithm, and we have 1 over 2 log x base 5 equals x to the power of 2. And again, let's apply the second rule by transferring 1 over 2 to the power of x. Here we have 5 to the power of log x to the power of 1 over 2 base 5 equals x to the power of 2. And finally, we apply the last rule, which is when we have the base to be 5 and the entire base of logarithm is also 5. So we are going to take x to the power of 1 over 2, which equals x to the power of 2. And here comes to the algebraic equations in exponent form. So we take the square root of the square of both sides. By squaring both sides, we get rid of power of half. And here we have x to the power of 1 over 2 all raised to the power of 2 equals x to the power of 2 all raised to the power of 2. So this cancelled, and we are left with x equals x to the power of 2. We multiply 2 and we have 4. On getting this, we have x equals x to the power of 4. Let's transfer x to the right hand side, and we are left with 0 at the left hand side. Therefore, x to the power of 4 minus x equals 0. And to solve for all the values of x in this equation, we factor out x. And inside parentheses, we have x to the power of 3 minus 1 equals 0. And by rule of 0, it means that we let x equals 0, or we have x to the power of 3 minus 1 equals 0. So we have already gotten the first root, which is x equals 0. And to obtain the other root, here is x cubed minus 1. And to find all the solution here, we let 1 to the power of 3, which is still 1. And here is a difference of a 2 cube, which the identity of it is x minus 1 bracket, open bracket, x to the power of 2 plus x plus 1 equals 0. That is, when we expand this, we are going to get x to the power of 3 minus 1 to the power of 3. Therefore, x minus 1 equals 0, or we have x to the power of 2 plus x plus 1 equals 0. So for the first one, x equals 1 is another solution that satisfies this problem. And for the other part, which is quadratic equation. Here when we consider a as the coefficient of x squared, which is 1, b equals coefficient of x, which is 1, and c is a constant value, which is also 1. So here we have discriminant, which is b squared minus 4ac, and this was derived from the quadratic formula. So by plugging all these values, we have 1 squared minus 4 multiplied by 1 multiplied by 1, that is still 4. And 1 minus 4 is minus 3, and this is less than 0. Obviously, when discriminant less than 0, we are going to get a complex solution which is not satisfy this, which means those values that satisfy this, which are real, are x equals 0 or x equals 1. And as usual, we are done with this problem. Thanks for watching, and if you have another way of doing this, you can drop it in the comment box. And please don't forget to subscribe to this channel and turn on the notification bell. Bye bye.